Good morning, everybody. This is Murali. I am from St. Joseph's Institute of Technology, Mechanical Department. In today's concept, I am just going to brief you and explain you about what are the latest technologies in unconventional traditional process and what are the latest techniques that are being evolved in laser and as well as wire cut EDM process. So the latest techniques is the latest research papers concludes different types of categorization of titles. So to be particular on precise, this title, that is experimental investigation on material removal rate and surface roughness on wire EDM on alloy. First of all, you have to choose the selection of material. The selection of material is a predominant factor in which the wire cut EDM is going to play a vital role, right? This alloy is a superalloy in which it's going to play its mechanical and physical properties, where we are going to machine very hardened and brittle material. Here as an abstract, first of all we have to know what is wire EDM. A wire EDM is an unconventional traditional technology in which it removes the material in conjunction with deionized water with a thermal zone between the tool and the workpiece. To be very crisp enough, we are going to define how the material removal rate is going to take place. We don't have any physical contact between the tool and the workpiece. With a single strand of wire, the wire can be of zinc or brass coated with molybdenum of diameter of 0.15 to 0.165 mm wire diameter can be used for this process. In this technique, I have given a very short descriptive abstract. In this process, I am just going to use a very important technique of design of experiment like the principal component analysis. There are various techniques available in the softwares like Takuji method, surface response methodologies. In this technique, I am just implementing the principal component analysis with the three mode of techniques of dielectric mediums. So what is dielectric medium? So very oftenly we are going to use a dielectric mediums in different types. The dielectric mediums can be used with kerosenes, you can use mineral oils. The most predominantly used dielectric fluid is a deionized water. The deionized water, we have a pH value that should not corrode the material, and as well as it should not have any negative impact on mission and as well as the superalloys. Yes, by using this technique, wire EDM is as I said in the previous phrases, wire EDM is a thermoelectrical energy between the workpiece and the electrode, in which it creates a very small discharge between the tool and the workpiece. So the electrical zone that created when the pulse on input is given, immediately what happens is an electrical spark discharge between the tool and the workpiece take place in such a way that the variable gap between the tool and the workpiece creates the debris of the workpiece and removes the material in the phenomenal way. So here we are going to have the contour of this topic is, I'm just going to have a brief introduction how the wire EDM is going to work and how to choose the process parameters. Each and every individual of the machines, we have a various process parameters. We have two different types of process parameters. One is input, other is output. So input parameters is completely differs from machine to machine, whereas the output parameters phenomenally will be only fixed like material removal rate, surface roughness, kerf width, and goes on like the sim analysis and microstructure. Then why we have to choose this thesis and why we are going to use the objectives methodologies, and in this technique and research work we are going to use a very special fabrication unit technique. That is, in this we are going to have three different types of modes, that is wet medium, dry medium and near dry medium. So what first of all is what is wet medium? So in the phenomenon factors in unconventional traditional process in all both in the industries and as well as in the college laboratories, we will be using only in the wet conditions. The wet condition is directly from the lubrication tank through the nozzle through the inlet flow of deionized water hits the workpiece and the material removal rate take place. So continuous flow of deionized water is called on wet condition. What is near dry? So near dry is it just nothing like, but we are going to have a compressor and as well as a nozzle fixing the various pressures. So for example, we are taking a compressor of 2 bar pressure to 10 bar pressure. We are just going to vary to 6, 4 and 8 along with the deionized water which is being sucked from the lubrication tank. through the nozzle, we are going to have a mist format in such a way that the material removal rate will take place in the phenomenal way, and the characteristics of the material and as well as the material removal rate and the surface roughness will be more significant when compared to the wet condition, right? The last comes to the near dry and the dry conditions. The dry condition is only with the compressed air. There is no need of using of any deionized water, no need of use of any other medium sources for machining. Only by using of compressed air through the nozzle, we are just going to concentrate on the workpiece, where we are going to machine a very eccentric and complicated surfaces in which based upon the designs. Next one is, for this we are going to fabricate one single unit. In that single unit, all the three mediums can be easily attained. So by fabricating this technique, what I'm going to do is, we are going to take the attachment kit, and by the side of the FRL unit, that is a fluid lubrication unit, we are going to attach this kit in such a way that the three modems, that is wet medium, dry medium and near dry medium, can be easily attained by this attachment kits. So most prominently, they will be using only a single mode by using this techniques. This attachment kit will help you and creates a more application and saves the more time, and the reduction of time will be easily obtained by using this kit, right? The next one is the selection of dielectric medium. As I said in the previous research papers, many dielectric fluids is available. Deionized waters, mineral oils and all the EDM oils are available. So most phenomenally in the industries, they will be using only deionized water. Why we are using deionized water? Because the pH level and the availability and the deionized water using the process will not corrode the workpiece and fixtures, and it will not create a more a positive impact other than creating a negative impact when it comes to the choosing of a proper dielectric medium. Next comes the machining outputs. As I said, the machining output is a phenomenal factor which are going to focus on based on the input parameters what we give, right? Input parameters is for wire EDM can be categorized in various types. To be precise and to be particularly on some examples. So for example, I am choosing an EDX50X. It's a particular machines that has been available in say various industries. In those machines, we will be using the input parameters such as pulse on time, pulse off time, wire feed and the servo mechanism. So this four parameters is a very input phenomenon factors for obtaining this machining output, for getting the material removal rate, surface roughness and kerf width. So what is surface roughness and material removal rate? This surface roughness and material removal rate, it gives you an impact factor, and whatever the material which we use, either it is conductive or both very high super alloys, right? The first phenomenon factor should be that is it should have a superalloys. So first of all, what is superalloys? The superalloys is a very hard material which cannot be machined on normal conventional machining process like lathe or shapers. Whereas when it comes to the wire EDM, that is untraditional process, this hard conductive materials with a high machinability index. The high machinability index material can be easily machined by using this wire EDM with this latest technologies, right? And last, I'm just going to have a result and discussion with a proper conclusion with the SEM analysis and the various categorization. Yes, as I said, the wire EDM is a process in which is in conjunction with of deionized water and creates a spark between the tool and the workpiece, in which the material get removed in the form of debris, and which in turn this debris will be flushed away through the lubrication tank by using of the concentrated nozzle with the various pressures, right? So this EDM machines can be used in the industrial applications for the complex material and the eccentric shapes and designs which cannot be machined on the normal traditional machining process. Yes, so this is the basic diagram. So this is the wire diameter and this is the workpiece, in which this wire diameter, the selection of wire diameter can be of two types. Either you can choose brass or zinc coated with molybdenum wire. This wire diameter is either it can be used of 0.5 to 0.9 mm diameter, in which it can be of a wire pool mechanism which is being connected with the wire EDM machine, right? First, this wire EDM, when connected with the positive and negative terminal, this wire EDM creates a spark in which in conjunction with the material, that material can be of either conductive or superconductive materials. This material removal rate take place based upon the path or based upon the design which we put, and it cuts the material, and debris will be removed as per the pressure and as per the pulse on time we given, right? So this, to stop the sparkling process from the spotting outward, we need to choose a proper fluid, and dielectric application should be proper. Yes, I have framed out the working of wire EDM in 4 basic steps, right? The step 1 is, first we are going to choose the wire electrode, and this is the material. The material can be either superconductive or it can be very hard material. So this wire EDM, what I want to do is, it's just going to surround the deionized fluid surrounded with the workpiece, which is being connected with the positive and negative supply of the EDM process. Step 2 is, it creates an electrical spark in which the path is created between the workpiece, and it removes with a very fine debris which is being flushed away in the dielectric medium. So last stage is, this tiny dots is the debris which is being removed based upon the input parameters which we give on the factors, right? So this dielectric medium and workpiece and the electrode is a phenomenon factor for choosing the process parameters while beginning the process is very important. Yes, this is the basic fundamental phenomenon factor for this research work is, first we have known what is the fundamentals of EDM, the selection of dielectric medium, tool and the workpiece, right? This dielectric medium can be categorized into different ways. Either it can be mineral oil, or either it can be the natural oils or vegetable oils, or deionized waters. Most phenomenally, they will be used only deionized water, or in terms otherwise we call it as distilled water, right? This tool is always we categorize into 2 categorization. One is zinc or brass coated with molybdenum wire. The workpiece can be it should be superconductive, and it should exhibit an electrical conductivity factor, and it should have a proper conductivity between the tool and the workpiece, right? So this fabrication tick, it's a phenomenon factor where, as I said in the previous slide, we can obtain the 3 modes, that is wet system, dry system and near dry system. The wet system is a continuous flow of process where the deionized water is going to flow on the workpiece in a very continuous or spontaneous manner. The dry is only by using of compressed air. We don't need any use of deionized water. Near dry is the combination of both. So what is wet condition and dry conditions combined together, we are going to have a near dry process in the form of mist format. So mist format is, we are just going to have a very fine tune of mist format, right? So for this, the special attachment kit is being controlled by using the 3 controls valve, that is flow control valves. By using the flow control valves, the 3 modes of mediums of deionized waters can be easily controlled to determine the factors on MRR, surface roughness, and by using the MRR and surface roughness output, we can easily analyze those techniques with the help of DOE, design of experiments, with various techniques available in the softwares like surface roughness methodologies, Takuji methods, and Gray relational analysis, bottleneck methods, mechanisms. In this technique, I have used the principal component analysis to define these techniques. Yes, this is the basic methodologies where a researcher, where students can take these methods as their projects, as research works for defining their assignments to take the process. First, we have to choose the material. In this technique, I have chosen hastelloy. Why hastelloy? Hastelloy is a superconductive and superconductive materials. This C276 exhibits a very good electrical and thermal conductivity with respect to the wire EDM process. So objectives, as I said in the previous slide, the main objectives of this process is to obtain the 3 modes, wet, dry and near dry, right? So in this method, I am just going to give an input. 4 factors of input. For those 4 factors of input, I am just going to take the 2 inputs. This inputs in terms of DOE, the design of experiment, that is principal component analysis. By using this principal component analysis, I am just going to conclude in what parameters and what input parameters which is being given on the machines to get a fine-tuned MRR and surface roughness among the various orthogonal arrays. There are different orthogonal arrays. You can go for L9, you can go for L18, you can go for L27. Among this, how optimistic values is, it's best to choose only L27. Yes, this is the ray diagram which has been designed by using various reference papers. This is, you have a compressor unit. The compressor unit, you can obtain a bar pressure from 2 bar to 16 bar pressures, and by using FRL is filter regulated lubricator unit, which has been controlled by the 3 FCV units, that is flow control valve 1 and flow control valve 2 and flow control valve 3, which is can easily monitored by pressure gauge 1 and pressure gauge 2. So this 3 parameters, flow control valve and the fluid tank, that is the deionized storage tank, which is being connected to all the 3 flow chambers, that is flow control valve 1, flow control valve 2 and flow control valve 3, which is connected to the mixing chambers. In this mixing chambers, you can obtain the 3 modes. Either you can have a direct wet mode through the nozzle, you can hit the wire and you can do the machining process, first condition. The second condition is dry condition, where you can close the where you can cut off the compressed air and you can use only the compressed air to get inside the mixing chamber and let the compressed air to enter into the nozzle, and you can machine it to define the defined value. And third one is you can use both the chambers open. Both the chambers open in the sense you get a compressed air, you get a deionized water, both combined and mixed together. You have a right proportion of the spray format which attain in the nozzle through which is going to concentrate on a particular zone where you are going to machine. So what about this nozzle design? So nozzle design is how precise the nozzle design. Either you can choose 0.75 mm to 1.25 mm, depends upon the application and depends upon the design where we are going to use for the industrial applications and what type of material you are going to choose. Yes, as I said, this is the exact attachment kit. So this is the prototype model. This is a fine refined tank. This is the FRL unit, pressure gauge 1, pressure gauge 2, and this is the mixing chamber. What we have tried is, we are going to attach this lubrication kit separately to the machine, which the process is going to be executed. Yes. Yes, before starting the research work, we have done many scientific research works by using of compressors, right? So this compressors can be connected directly to all the valves, that is this FRL unit through the pressure gauge 1 and pressure gauge 2 and the mixing chamber. This mixing chamber is being connected to this nozzle. You can see this nozzle. This nozzle is being fixed, which is being focused on the material where we are going to machine and where we are going to take place the hardened surface, where we are going to machine the surfaces with a very phenomenon factor. Yeah, this picture is very much precisable and viewable. We took this wire cut EDM process machine, and the industry is called V-cut in Gumudi, and this separate attachment kit is being attached to the machine, and where in this case is the deionized lubrication tank from the lubrication tank is being cut, and this kit is being connected to the direct lubrication chamber. Yes, this is the basic attachment kits. The compressor, as I said, you can use the various categorization of compressor, that is 5 to 12 bar, FRL unit, a tank, a mixing chamber, nozzle, a pressure gauge, and flow control valve 3, 1 and 2. Yes, the dielectric medium. Now I am just going to describe how the dielectric medium it should be works on. Normally, while choosing the dielectric medium, the medium should not conduct the conductivity or electricity, right? So most phenomenon factor for the dielectric medium, it should depend on the workpiece, the type of the shape, the tolerance, surface roughness, and the surface finish. Yes, the main important thing is, the most important thing is the function of the dielectric medium. So function of dielectric medium is, it should act as an insulating medium. What is insulating medium? So the main insulating medium should have a proper electrical conductivity, and it should not have any negative impact on the mission fixtures, right? So it should cool the spark regions, it should erode and it should flush the particles and debris along with the flushing pressure, and it should maintain a constant resistance across the gap and tool and the workpiece, right? So for that we have taken many sources from the research papers, from the industries and inputs. We have designed the three patterns for wet system, deionized water, dry system. We are using only of compressed air, near dry. Combination of these two factors, air plus compressed air, we are going to have in the mist format. So this, all the phenomenon factors you can be obtained in this factor. See, this is FRL unit. This FRL unit is being connected with the pressure gauge, and this pressure gauge can be easily monitored when the pressure can be decreased or increased right from 5 bar to 12 bar. Yes, this is the phenomenon factors where we are going to choose the mechanical, thermal and the electrical properties of dielectric medium. So just blindly we cannot choose the deionized water such as kerosene, hydrocarbon oils, water, air. So here we are just focusing only on deionized water. So deionized water, it should have a proper phenomenon characteristics like dielectric strength, dielectric constant and thermal conductivity and heat conductivity. Among this phenomenon factor is you should have a proper thermal conductivity. Thermal conductivity is you should obtain the conductivity between the tool and the workpiece. So among those we are just going to concentrate only on deionized water. Yes, this is the selection of material. The selection of material can be of your choice based upon the availability, based upon the budget of the material. Here I have chosen is nickel based alloy, that is Astalloy C276. In this Astalloy C276, the nickel chromidum and molybdenum alloys play a phenomenal role. Why? Because the percentage, that is chemical composition of nickel is very higher. So in the upcoming slides I will be showing you the nickel percentage is 73 to 65 to 85% of composition is available in nickel, since as we all know a nickel is a very good electrical conductivity and it holds a very good thermal conductivity during the machining process. Yes, this is the basic structure of an Astalloy, which a dimension of 10 cross 50 with a thickness of 5 mm. Normally we choose the material depends upon the fixture and depend upon how we are going to cut the material, whether it is eccentric or whether it is complex material and what way it is going to design. So we have chosen as 10 cross 10 into 5 mm, that is 10 mm length and 110 mm breadth and 5 mm thickness plate. So this is the basic properties. The chemical composition, as I said, the nickel copper is a higher percentage, since the nickel plays a phenomenal role, which it have a very good thermal conductivity. Yes, now we are going to talk about a very important factors on applications, right? So wherever we take up the applications, the most phenomenal thing is application is going to work where we are going to use, right? This application is the wire cut EDM. You can use it in both industries like automobile sectors, aerospace, nuclear power plants. So the most important advantage is cutting the eccentric and complex design. What do you mean by eccentric design and complex design? In the sense, cutting of hard material with a complex shapes can be easily obtained in this process, right? So just like the desulfurication plants, heat exchangers, filters and other all complicated machining process can be easily obtained. Yes, now I am just revealing how we are going to choose the parameters, right? So basically these are all the input parameters, that is pulse on time, pulse off time, voltage, wire feed. This is the air input and flow rate. The flow rate is MQL, the quantity of deionized water which is being discharged to the nozzle, which is going to hit on the concentrated material, right? So normally we are going to choose the three parameters: low, medium and high. Many of the students or many of the researchers may get different queries why these factors has been chosen, right? So you cannot choose the fixed value. So when you're choosing the fixed value, you should have the range, right? The range should be of low, medium and high. Among those three, we have to take the average value which suits the machine and which is going to execute without any complex shape, right? So pulse on time is 2, 4 and 6. Pulse off time is 3, 6 and 9, and voltage is 45, 55, 65 and goes on. That is the feed. So this is not a fixed one, depends upon the machine which you are going to choose, it's going to differ. Yes, I have chosen L27. As I said, there are different categorization, L18, L9 or L27. To get the very best optimistic result, the researchers, they only go for L orthogonal 7, it's 27, right? So I have chosen by using of Minitab software, I have chosen pulse on time, pulse off time, voltage, wire feed and the air pressure and the flow rate. I don't want to explain all 27 experimentations. I will explain only one, right? So first factor is I am just going to fix the pulse on time 2 and pulse off time 3 and voltage 45 and wire feed is 2. But then by using of the wire feed, and I am just using a pressure gauge of 2. By the flow rate is by using of mathematical derivation, the flow rate of 1240.5 flow discharge is being heated through the nozzle and the machining take place. For those value, what is the MRR, what is the surface roughness and what is the kerf width. So for all 27 we have done the experimentations by using various reference nodes, we are by using various industrial inferences, we have taken this inferences. So this is the experimental machining output. So as the parameters T on, T off, voltage, wire feed and air pressure is all the input parameters. So based upon the input parameters, we are going to note down the time. So time is a phenomenon factor for choosing the MRR, surface roughness. So first of all, what is MRR? What is MRR? So material removal rate, that is the volume of material removed per unit time. So unit time, material removal rate per unit time. So for those material removal rate, so this factors, that is 2, 6, 45, 2 and the air pressure of 2 bar with the flow rate of 1240.5 within by using of with the IC current of 0.6, the machining timing is obtained as 0.2 and the time is being taken with the minutes, and for that the kerf width. The kerf width is the wire which is being traveled between the path across the width. That width, top and bottom width is calculated, and the surface roughness and the MRR can be calculated. So this MRR can be calculated either in two techniques. That is before and after machining process, and this surface roughness can be calculated with by using a special technique called a 3D profilometer, where you get the three values right: RA value, RY value and RX value. Yes, now I am just talking about a very important design of experiments, that is principal component analysis. So principal component analysis is the design of experimentations where you can step out and where you can optimize the values. So I don't want to describe much, so I'll be explaining you what are all the mathematical derivations, right? So first thing is signal to noise ratio, where you're going to compute the analyzing stage. From we are going to transform the SN values for the each response. And third step is we are going to perform the NX values with the principal components, that is the input parameters versus the output parameters. So next is the last one is we are going to compute with multi-response performance, that is we call it as MPI, corresponding to the each trial. And last one is depending upon the ANOVA analysis, we are going to have a combinational factor. By using MPI and ANOVA, we can easily conclude. So these are all the basic factors which I explained in the previous slide. Yes, so this is the value. So larger value, that it indicates that, so for level 1, level 2 and level 3, the pulse on, that is I am indicating as A, B, C, D. So we can easily find out the sequence, that is A1 to B1, B1 to C1, C1 to D1 and E1. We can easily choose the sequence. So as I in the previous table, the larger value of mean performance index implies the performance values where the optimistic values can be obtained in this sequence, that is B B2 to B1, A2 to B1, and C2 to D2, and E2 to D2. So this parameters value have the optimized parameters values, that is pulse on time is 4 and pulse off is 6 and wire feed is 3 and voltage is 55 and the air pressure is 4 bar. This optimistic result can be obtained in this sequence by using the parameters in the previous slides. Yes, now I am just going to have a fine conclusions for my result analysis. So I have chosen the result and discussion on for two phenomenon factors. One is on material removal rate and other one is for surface roughness, right? The first is for material removal rate. The inference gives you the plot voltage. It's much being preferred on, T off and wire feed. So I mean pulse on time, pulse off time and wire feed as a phenomenon factors with respect to which the material removal rate, it can be have a proper much greater in the sense it's have a more significant factor. Next is surface roughness. The surface roughness is the plot gives you the leveling one, that is T off, Ty and T2, in which the SN ratio and the surface roughness have a smaller is better. In the MRR, larger is better. For surface roughness, smaller is better. The analysis shows you the impact factor for MRR, the pulse off time, that is T on, creates the significant factors for the material removal rate. The pie chart basically shows you that the 95% and remaining is 1 or 1.2 or 3% impact shows that the material removal rate on optimistically by changing the pulse on time creates a great impact while other impact choosing. So this is on surface roughness. So surface roughness creates an impact on by choosing a wire feed of 69% and the 15% on pulse off and 14% of voltage, where you can easily conclude that by using a proper wire feed mechanism we can easily obtain a proper surface roughness. So by using this SEM analysis, I have chosen the 7 among the 27 parameters. I have chosen SM images for one for the very low surface and one is for very high surface, that is 1.84 microns and 4.05 microns. So in this microns, the cluster distribution, you can easily see the clusters are very closely impact and atomic bondings has been closely impact, whereas in the surface roughness of 4.05 microns, the clusters is very unevenly distributed. You can easily obtain in this graph. So comparing the two images, the higher surface roughness and the atoms have been well defined boundaries. It has a well defined boundaries, and the clusters on the formation of surface roughness can be due to various factors like high voltage, less tension on the wire, or intermediate power cuts, or any unskilled labors during the operational process. Yeah, I am coming to the final conclusion of this process. The wire EDM, that is 4 input parameters, that is MRR, surface roughness and wire EDM. Among these 3 factors, wet, dry and near dry, this research papers have a very fine-tuned process. The near dry, it's a factors which gives you a very polished surface finish, and the material removal rate is a very fine rate when compared to dry and near dry, right? By using this Minitab software, the very performance, that is larger is better. The principle has been obtained for surface roughness, whereas the smaller is better for the principle where we are going to use for surface roughness and MRR, right? So as I said, the last concluding part, this is among the 27 factors, these are all the optimistic value, that is for getting a process parameters for the better MRR is 0.0596 grams per minute and surface roughness is 3.80 microns. For obtaining the optimum combination of process parameters for MRR and the surface roughness is by using the MPa implexing values that shows that the sequence A1, B3, C3, D1 and E1. So phenomenally, the sequence factors will tell you which factors have a phenomenon role and which factor is going to impact on the process. So I'm concluding this research paper with a very fine-tuned process stating that the near dry process is the phenomenon and the latest technologies which is booming on the various technologies. So friends, hope this videos is very good for you. Until then, I'll catch you on another video with a more informative and with the latest technologies available. Thank you and see you on another video.